Take a look at proving quadrilaterals in the coordinate plane, part 1. There are going to be 3 videos. Again, you're going to make a tab called quadrilateral proofs. You're going to pause the video. On the right hand side of the first page, copy these 2 examples down. Each example take about half a page. Turn the page over. On the left hand side, copy these other 2 down. Alright, so like anything we're doing, we have to know the properties. So I'm going to run you through the properties once again. So in the quadrilateral family, you have a kite. And a kite looks like this. Is a listening check. Put a box around the word quad and color it in. You then have a trapezoid with exactly 1 pair of parallel lines. And actually, with a trapezoid, you also have like a special kind of trapezoid, which is an isosceles trapezoid, which is just like a trapezoid. The only difference is that the sides on the side are congruent and the base angles are congruent. By looking at the kite, the most obvious adjacent sides are congruent. Draw diagonals. The short ones bisect each other. All the middles are 90, and 1 pair of opposite sides are congruent. With a trapezoid, I forgot to say, an isosceles trapezoid, the diagonals are congruent. I forgot to say it in the previous video, so I'll say it again. Isosceles trapezoid only, diagonals are congruent. Alright, also in the quad family, you have the parallelogram, a nice loose mark. You have exactly 2 sets of parallel lines. Opposite sides, opposite angles are congruent. Then consecutive angles, they add up to 180 or supplementary. And then the last one has to do with diagonals. Diagonals bisect each other. This is a listening check. Color in this parallelogram. Alright, the parallelogram gets with the baby daddy, gives birth to a rhombus, which is a slanted square. What's the most obvious about a slanted square? All sides are congruent. And then the rest have to do with diagonals, which is they all meet at 9 in the middle, which are perpendicular, and then it bisects the vertex angles. Also gives birth to a rectangle. Most obvious is that vertex angles are all 90, and then the last one is diagonals are congruent. Then they give birth to a square, and the square has everything everyone has, so it has a total of 10. For listening check, write the words all 10 in the square. Okay, so that's a quick review of the properties. You have to know them. Okay, now let's get to why we need this. A couple of things that you need. Distance. When you're talking about distance, you're talking about proving lines are congruent. Lines are the same when the distance is the same. When you're talking about midpoint, you're talking about you're trying to show that lines bisect each other. What that means is that they cut each other in 2. And then when you're talking about slope, you're talking about whether the lines are parallel or whether they're perpendicular. If they are parallel, the slope is the same. So I'm going to say that again. If 2 lines are parallel, the slope is the same. If 2 lines are perpendicular, you will take your slope, you will flip it, change the sign, and if they're the same then the 2 lines are perpendicular. So I'm going to say it again. You'll take your slope of one, flip it, change the sign, and if it's the same as the other, then the 2 slopes are perpendicular. Alright, so let's take a look at our family tree again. So in proving all of these, we don't have to go through all the properties. Like in a kite, there are like 5. We don't have to do all that. We just have to do adjacent sides are congruent and, okay, so you prove that adjacent sides are congruent and that they meet in the middle at 90 degrees. Okay. When you're looking at a trapezoid, that one's probably the most easiest. You just need to prove that exactly 1 pair of parallel lines, but you also have to prove that the other side is not parallel, because otherwise it could be a parallelogram and you don't know. So exactly 1 pair of parallel lines, and then that the other side is not parallel. With an isosceles, you're going to do the same thing you did for a regular trapezoid, but on top of that, you're going to prove that the diagonals are congruent. This is a listening check. Underline the word exactly. Now when you look at a parallelogram, now again, let me just say this. Instead of us proving all 5 things, we're just proving a couple of things. But you need those couple in order for it to work. You have to prove exactly 2 pairs of parallel sides. So if you prove that opposite sides are parallel, then you're good. And that has to do with slope. So let me actually go back and correct these. Alright, so adjacent sides are congruent is distance, and then 9 is in the middle, is going to be slope. Exactly 1 pair of parallel lines, that's going to be slope. That's going to be slope, and also diagonals are congruent, that's going to be distance. So these are the formulas that we're going to need. Alright, so then a rhombus, you can prove all the sides that are congruent, Now, if you prove all the sides are congruent, that's also going to prove a square. But remember, and that has to do with distance. Remember, a square is a rhombus. A square is always a rhombus because it's the kid, right? So if I prove all the sides are congruent, it's also a rhombus. For a rectangle, we're going to prove all the vertex angles are 90. And once again, that's also true in a square. But if you prove all the vertex angles are 90, you've already proven a rectangle because the square has everything. Alright, then finally with the square, we're going to prove all of them are congruent, but we also have to prove like one of the corner angles is 90, because if we proved all the sides are congruent, it could be a rhombus. So we also have to prove one of the sides is 90, because if one of the sides is 90 and all the sides are equal, it can't be a rhombus. So that has to do with distance and slope. And you're going to realize that I really stayed away from the midpoint, but you could use it if you want to, and you can ask me in class and I'll show you, but you could use it on the parallelogram if you want. Alright, so let's take a look at an example of how we're going to put this together in the next video.
What did I get into?